Oh, hi. I hope you don't mind that I'm eating. This is actually just my first course. For my birthday, the writers wrote me a script where I just get to eat the whole time. And I can't think of a better way to demonstrate the workings of the digestive system, the series of hollow organs that we use to break down and process nutrients and energy we need to function. Though, wait a second. If I remember correctly, digestion is actually pretty freaking disgusting. So maybe I shouldn't be eating right now. But whatever. Waiter! The digestive system is so fundamental that it's basically step number 1 in the guide to how to make an animal. You probably remember that during the embryonic development of most animals, the digestive tract is the very first thing that forms. When the blastula, that little wad of cells that we all used to be, turns into a little wad of cells with a tube running through it, that tube is your digestive system. And pretty much every animal has a digestive system of some kind, but they're not all alike. Far from it. In fact, digestive tracts are specially adapted to animals' feeding behavior and diet. For instance, a housefly eats mostly liquid or very finely granulated food, but before it does that, it's got to puke its digestive juices all over its lunch and then let them digest it for a while before it sucks it up into its mouth. If we did it like that, first dates would be less common. Most vertebrates put food in one end of the tube and our digestive system processes it, and then it gets rid of the waste out the other end of the tube. No muss, no fuss. Well, actually, there's a little bit of muss at the end, you may have noticed. But the beauty of it is that this whole process is run by our autonomic nervous system, so we don't have to think about it until maybe the very last step when we're in traffic and just had 2 cups of coffee and a bran muffin. Then we have to think about it a little bit. Among vertebrates, the digestive tract might be short or long or have organs that do different things depending on what its feeding habits are. For instance, dogs are mostly carnivores and also scavengers. They mostly eat meat, but sometimes that meat's been dead for a while. So the dog's digestive system has developed to take food in, absorb as many nutrients as possible, and then deposit it on somebody's lawn all in a period of about 6 hours. Dogs have an extremely short digestive tract because if you're in the habit of eating rotten meat, you'd better be able to digest it fast. If you don't, the bad bacteria that's probably living on that armadillo carcass is going to take up residence in your gut and put you in a world of hurt. Cows, on the other hand, take a very, very, very long time to digest their food, around 80 hours, because they have to process plants, mostly grass. Grass has a ton of cellulose in it, and evolution has yet to produce an animal that can manufacture a stomach acid or enzyme tough enough to break down cellulose. So cows have microorganisms in their guts that break down the cellulose for them. This process takes a 4-chambered stomach, each one with a slightly different microecology, and a lot of cud chewing, or regurgitating and rechewing of grass, before it passes all the way through. So nature is full of crazy digestion stories, and I honestly wish that I had time to tell them all. But let's focus on human digestion from now on, mostly because you're probably a human, we don't assume anything here, and you'll be wanting to know how your body does all this stuff. And 2, humans actually have a pretty good all-purpose digestive system. We're omnivores after all, we eat plants and meat, so our systems are generalized to handle all kinds of stuff. Like most animals, humans have a bunch of different acids and enzymes in our digestive tract that break down food so that it can be absorbed and used by our bodies. But the secret to successful digestion is maximizing surface area, in more than one way, actually. The first way we maximize surface area is on the food itself. So say I take a bite out of this apple. Right now, it's like an apple boulder sitting there in my mouth. I got enzymes in my saliva that immediately start breaking it down, like the outsides of the boulder. As I swallow this chunk whole right now, not only would it hurt like heck, the rest of my digestive system would have a really hard time dealing with it because most of the enzymes and acids would have the same difficulty working all the way through this big solid hunk. But when I use my awesome teeth to chew up this hunk of apple, suddenly there's double, triple, quadruple the surface area on the food. I'm making up apple gravel from the apple boulder. Maybe even apple sand. For humans, chewing is key because breaking down our food into smaller and smaller bits allows enzymes and acids to get at them. And after our teeth have made the pieces small enough, the chemicals break them down further until they're fine enough for our bodies to absorb nutrients from them. But it's not just the surface area of the food that's important. The surface area of the digestive system is key to the whole process as well. Last time I talked about how we have a whole bunch of surface area in our lungs to absorb tons of oxygen all at once. Well, our digestive system works in much the same way. Most of the absorbed absorption of nutrients happens in our small intestines, and the length of the average human adult's small intestine is about 7 meters. Plus, inside our small intestines there are a bunch of little folds and little absorbing fibers with absorbing fibers on them, and no, I didn't misspeak, the fibers have fibers. That's how hard our intestines work to increase their surface area. Last episode, I was all impressed that lungs have a total surface area of 75 square meters. Well, the small intestine has a surface area of 250 square meters. Ugh, it's kind of gross. I wouldn't want to see it spread out over a tennis court or anything. But I'm getting ahead of myself here. Digestion does not start at the small intestine, people. It starts at the mouth. Now, as you can see, this Hot Pocket is surrounded by some kind of bread, if you can call it that. Bread is a starch which breaks down into glucose. When I start gnawing on a piece of bread, you got the outside here, so it's mostly bread. The glands in my mouth start secreting saliva, which contains salivary amylase, an enzyme designed to break down starch into glucose. The more I chew, the more amylase will get to all the different sides of the bread, and that's why the more you chew bread, the sweeter it tastes. Amylase doesn't really do much to the meat or the cheese in this thing. I've got other enzymes and acids that are gonna work on them later on in the system, but I am gonna chew all that stuff up real good right now so that those other enzymes can do their jobs later. I'm gonna swallow all this. So now the masticated Hot Pocket has passed down my pharynx or throat and into my esophagus, which leads to my stomach. There's actually this little cool flap of tissue called the epiglottis that blocks the trachea when I swallow so that the food doesn't end up in my respiratory system. So this ball of food that I just swallowed actually has a scientific name. It's called a bolus, and it rides a kind of wave of muscle action down the esophagus into the stomach. This wave-like contraction of the smooth muscles around the tube of the esophagus is called peristalsis, and it's basically how most of the movement in your digestive system is accomplished. Now, my Hot Pocket bolus is in my stomach now, which is where the food really starts getting manhandled. The stomach basically takes a scorched earth approach to digestion. It's not messing around. It's like a churning cement mixer that can contract and expand with these big accordion-like folds of muscle called rugae. Your stomach's job is to turn everything over and over, smushing and mixing all the pieces up with its cocktail of acids and enzymes called gastric juice. Gastric juice is mainly made up of hydrochloric acid, an enzyme called pepsin, and some mucus and water. Hydrochloric acid has a pH of about 1, which is strong enough that if you got it on your hand, it would give you a chemical burn, so the acid breaks things down and hopefully kills most of the bacteria that you might find on your food. And the pepsin starts breaking down proteins into amino acids. Now that mucus is important. It's there to protect your stomach so that it doesn't, like, digest itself. When you don't have enough of that mucus, you get peptic ulcers, which happen when your stomach lining comes in direct contact with your stomach acid. And the water's just in there to make everything all soupy, because what you want by the time your food leaves your stomach is chyme, which is a kind of liquidy slop that you might be familiar with from the last time you had a stomach virus. You know, this conversation was going to have to get a little bit gross, and I didn't want to bring diarrhea into it too much because, you know, I've been eating. But when something bad is going on in your digestive tract, your body doesn't worry too much about absorbing nutrients. It just wants to get the chyme out of there. So chyme is what you see when you get the picture. Anyway, there's a little valve or sphincter between the stomach and the small intestine that regulates how much chyme gets into the small intestine and when it gets in there. The very beginning of the small intestine is called the duodenum. This is where a lot of the small intestine action happens, by which I mean lots of things get absorbed and also secreted, like bicarbonate, which neutralizes the gastric acid before it goes any further. Now, the coolness of the small intestine can't be overstated. It's ground zero for cellular exchange of nutrients and the breakdown of fats. And again, the reason it's so good at absorbing is because all of the surface area it's got going on. A lot of that surface area comes from the fact that despite its name, your small intestine is frickin' long. In a human, it can range anywhere from 4.5 to 10.5 meters. But that's not all. The whole inside is lined with epithelial tissue that has tons of ridges and folds in it. Surface area to the max. And on those ridges and folds are these little hair-like fibers of flesh called villi. Each villus has capillaries on it so that it can absorb nutrients. And get this, each villus, which is only like ½ millimeter long, is covered in teeny tiny little microvilli, providing even more surface area. In fact, apparently, the small intestine has a texture kind of like velvet, which is... Oh, great, now I eat the milkshake? Fantastic. Okay, so another thing the small intestine does with the help of its friend the gallbladder is break down fatty stuff, like this milkshake. Near the top of your small intestine is a little pipe where bile salts manufactured by the liver and stored by the gallbladder are squirted out into the small intestine. Bile works like dish detergent on a pan you just fried something in. It's an emulsifier. It takes hydrophobic fat molecules and breaks them up into fatty acids and monoglycerides, which can be absorbed by all that epithelial tissue. I've never had Chunky Monkey before. Nuts. After your food passes through those yards and yards of small intestine, the chyme goes through another sphincter and enters the cecum, the beginning of the large intestine. The large intestine's job is to remove most of the water and bile salts from the chyme so you don't have constant diarrhea, so you can thank it for that. It's called large because it's wider than the small intestine, but it's not nearly as long. It's basically just a 1.5 meter victory lap around the outside of the small intestine, and then it calls it good. Also, should mention, at the end of the cecum there's a little tube where the appendix comes in. For a long time we thought that the appendix was a worthless vestigial structure that we used to need at some point in our evolution but didn't need anymore. However, recent studies are finding that the purpose of the appendix in modern humans is probably to act as a safe house for all of the good bacteria you need to help you digest your food. If you get a virus or food poisoning or something and all your digestive systems say, "Get it all out of me!" the appendix has a little sample of your gut bacteria that it spits out to help you recolonize after your illness. So I think you're probably familiar with the final step in the digestive system. That's the pooping. Your food can spend as long as 3 days in your digestive tract, and a lot of that time is spent in the large intestine, mostly reabsorbing the excess water from the chyme and prepping your poo for its great entrance into the world. When it's done, it passes through everybody's favorite sphincters, the anal sphincters. There are 2 of them, and out in the world to live its own life. And that's the end of our little tale here that begins with the Hot Pocket. I hope you join us next time for more disgustingness as we discuss the details of the excretory system. Until then, bon appetit. Thank you for watching this episode of Crash Course Biology. If you want to go back and review anything, table of contents, just click on it. Thanks, of course, to everybody who helped put this episode together. If you have questions for us, please leave them in the comments below or on Facebook or Twitter, and our team of experts will attempt to answer. Goodbye.